discuss the principal construction and the working mechanism of a cyclotron. So what is a cyclotron? So the cyclotron is a specific kind of a particle accelerator that can accelerate charged particles to very, very high velocities so that those charged particles can then be used to bombard onto some target nucleus to induce some sort of a nuclear reaction or perform some kind of a nuclear experiment. The first ever cyclotron was developed by Lawrence and Livingston in 1929.
Proton and neutrons. This results in production of high energy charged particle. In nuclear physics, such energized particles are used to bombard nuclei causing nuclear reactions. A positively charged particle can be accelerated to high energy with the help of an oscillating electric field by making it cross the same electric field time and again with the use of a strong magnetic field. If the time taken to complete one circle is t, then the time taken to complete semicircle would be t by 2. As soon as the particle comes to end, it is influenced by electric field. When the particle was born, its velocity was 0. When it enters the d, its velocity is v, and it is constant because the magnetic field cannot change the velocity. The oscillator will change the polarity. When it comes out of d, it again comes under the influence of electric field. The electric field accelerates the charged particle to v1. When it enters d2, the velocity would remain
So the cyclotron takes advantage of the circular motion of a particle in the presence of a perpendicular magnetic field to make the particle revolve in circular revolutions over and over again in a small region. Now, that itself is not enough, because even though a charged particle is moving in a circular revolution, that only changes the velocity direction. It does not change the magnitude of the velocity. So what else happens inside the cyclotron to increase the velocity of the charged particle? So to understand this, we have this particular setup. So these two half cylinders, D1 and D2, are connected to an oscillating potential. So there is some kind of a potential difference between one half and the other half of the cylinder. So there is some kind of a potential difference between D1 and D2. Now this oscillating potential is like some kind of an AC voltage, alright? So at some point in time, D1 will be positive and D2 will be negative. In some other point in time, D1 will be negative and D2 will be positive. And
when we place a positively charged particle, which may be a proton or a combination of proton and neutron both, since D1 is positive, D2 is negative, there is an electric field between them. Now a force acts upon the charged particle and its direction would be the direction of E. Because of this force, the charged particle gets acceleration, and because of acceleration, the speed increases till it enters the D.
Executes a circular trajectory, but that has a radius greater than the earlier circular trajectory. Now again, before it is about to exit D2, again let's suppose the polarity gets reversed. So this becomes negative, this becomes positive, and the electric field also gets reversed in direction. So again it accelerates, and then again it has a larger sort of a radius of a circle. Then again the polarity reverses, right? And again it gets accelerated, and again it executes another larger sort of a semicircle. Then again the polarity gets reversed, again it accelerates, again it experiences a larger semicircle. So this process keeps on happening over and over again, so that at every time the particle is about to exit any one of the D, the polarity is reversed, so that the particle only experiences an electric field pointing in the direction of its motion, so that the particle gets accelerated and its velocity gets increased consecutively. So if the velocity gets increased, now the radius executed by its trajectory will also be greater. So
if the velocity of a charged particle increases, the radius of the charged particle would also increase. Finally, when the particle has no more space to grow in radius, it is thrown out through a window. With such a high velocity, the particle has high energy and it hits the target.
to bombard to some kind of a target nucleus to perform some sort of a nuclear experiment. So this is the general idea of a cyclotron and a synchrotron. A cyclotron fails at relativistic speeds, but a synchrotron takes over by modulating either the oscillating potential or the magnetic field to keep both these two waves in phase. That's it for today. Thank you very much.